Yeah, welcome to JavaPro. My guest today is Thomas Much, and about mob programming and ArchUnit. Yeah, welcome, Thomas. Great to have you in this interview, and thank you for being with us at JCON.
Yeah, hi, Markus. Thanks for inviting me. It was great fun to present some talks at JCON.
Yeah, how was JCON for you? How was the audience? So
it was an amazing experience. We had lots of talks, lots of interactions with all the attendees. It was a really big online conference, and it was just fun, and it was amazing. Thanks for organizing this event.
Yeah, great. Thank you. Maybe Thomas, can you introduce yourself briefly?
Yes, I'm Thomas Much. I'm living in Hamburg with my family, and I'm a software developer, architect sometimes, and I'm a coach for agile engineering practices. That is, if you want to do something like pair programming or mob programming, I can join your team and help you for some days or weeks or even months, and we can develop software together.
Yeah, great. Thomas, your talk was about mob programming.
Yes.
I've never heard this. So what is actually mob programming?
Yeah, mob programming is about a bunch of people working together on one task. And mob is a funny name. You can say group programming, team programming. Some call it ensemble programming, like a band or an orchestra working together on one task. And if you say, hey, we're a group of people, we are a team, the question is, are you working in parallel on the task split up into several subtasks? Or are you really working on this one task together? You start together, you work on it together, you finish it together at the same time, in the same space, on the same computer. And that's really vastly different to working as a bunch of people working for the same boss. You're working as a whole team on one task.
Hey, this sounds a little bit like extreme programming. So is this related to extreme programming or is it different?
It's modern programming practice that fits really well into extreme programming. Extreme programming offers suggests pair programming, which is around with us for, say, 20 years or 25 years. And pair programming is a good practice as well. But we've had several problems with pair programming because pair programming is one-on-one. And the people must match perfectly. Otherwise, it can be really exhausting or stressful. So mob programming is kind of a new idea, a further development of pair programming to develop software with more than two people. And the interesting thing is that if we've got more than two people, you lose all the stress and the exhaustion because it doesn't depend one-on-one. You've got a larger group and there's always one who understands you, who understands your question, who can answer your question. So all the problems with team development and team building and working together without stress, without exhaustion, that's a lot easier with mob programming because you've got a whole group of people who want to solve one task. But it fits nicely with extreme programming, indeed.
Yeah, actually, we are all used to implement important features quickly and a good quality to customers. But you say in reality, sometimes this is different. Why?
Because if you look at what we're doing, if we're working in parallel, is that each one of us is occupied, is busy as much as we can to develop really cool features because we're the best developers, aren't we? And in the end, we find that all the pieces that we've built separately don't fit together. Maybe because we didn't understand each other what we want to build. Maybe we all built some cool pieces of technology, but even our interfaces that we might have developed together, the implementations don't fit together. So if you split up work and work too much in parallel, it's easy that you spend a lot of time discussing, reviewing like pull requests, and finding out in the end that you have to refactor all this important stuff and maybe start from scratch again. And when we're doing mob programming, we're working together on this one task, discuss the problem, try something, see if it's working. And if it's not working, we can just throw it away, start again. But every developer understands what we're working on and why we're changing ideas, why we dumped some code, why we take on a new approach. So every developer gets the idea and understands what we're doing. And this is, we call this early integration of ideas and not late integration. All this pull request stuff, where you do lots of reviews and spend lots of time waiting for each other, we just stop doing that and work together. And that's a bet that this approach takes less time. And that's a bet that's often won, actually. And you get team building, you get common understanding for free.
Yeah. I could imagine that maybe many decision makers are worry about the costs of mob programming. So is this more expensive, or in total even cheaper than the classic approach?
I don't know of any scientific research that has been finished on this topic. So this all is a bet that we're spending. We're betting that this approach is at least no costlier than the work we're doing before, but no one has proven that the classic approach, the traditional approach, that the traditional approach is cheaper than anything else. It's just, we're just used to for decades of working this way. And the question is, do and check what your total time of work is from the idea until it's delivered to the customer. And you'll find lots of waiting time that's wasted. For example, the pull requests and the reviews, you're waiting for each other, you're wasting your time. And maybe you have to throw away and refactor large parts of your code. And that's the total time it takes for delivery of one idea to the customer. And if you compare this to a solution developed as a mob, and a mob is a bunch of 4 to 6 people, that's not a 30 people team. That wouldn't make sense. So it's a team of 4 to 6 people. And if you take into account all this waiting time and all this waste, it's, I think my experience is that it's cheaper because it takes a lot less time to develop this feature and to deliver it to the customer if all the necessary people work together.
Yeah, sounds interesting. And yeah, what's about distributed teams, or as we have it today, working remotely in this COVID situation? So how does this work?
Yes. There was a pretty famous team at InnoQ who developed remote mob programming last year, the year before, but they published their ideas last year. So the whole community had a chance to get their ideas already at the end of last year. And actually, I started remote mob programming at the beginning of 2020 when I was coaching a remote team, a distributed team. That was just weeks before we had the first COVID lockdown. It wasn't actually a lockdown in Germany, but it was weeks before the situation. So we were prepared of doing mob programming remotely. And actually, that's a huge benefit if you learn how to work together, because remotely, once it turns off the camera and I don't know if you're still there, if you're working with me or if you're doing something else. And when we're working, when we're doing mob programming or ensemble programming remotely, all of us will turn the camera on, we'll see each other all the time. We're sharing our IDE or hand over our code via Git pushes and pulls. And we keep our team together because we're working together on this one task. And remote mob programming is actually not that difficult. Sometimes it feels easier than co-located. I wouldn't have said so some month ago, but it helps your team to stay together and to stay focused on one task. And you need some toolings, you need some basic ideas. I'll talk about some of the ideas in my presentation about my programming. And yeah, it's helpful to not fall apart, to keep the focus on delivering software, on solving your problem. Yeah.
Yeah, my last question actually would be, for whom is it suited? But it seems for me it's really suited for every developer team, especially in this COVID situation, working remotely together, right?
Exactly. That's what I would say. So, but I'm biased, so be careful. But I think it's helpful for nearly every team. The question is just how much remote mob programming will you be doing? There are teams who are doing remote mob programming 100% of their time. And it feels great for them because they deliver software in a flow as a whole team, because they don't have waiting time. They have a lot less waste, but that's not necessary. I find it helpful if you learn how to work together this way, that you can at least say once a week, collaborate 2, 3, or 4 hours this way. Then you learn how to use it, and you suddenly find situations where you say, oh, why should we do this alone? Let's do this as a mob. Let's do this mob programming style. And you realize that you want to do it more often. You shouldn't do it less than once a week because otherwise you don't learn that tool, and you must learn it a little bit. You have to do some experiments with it, how it works best for you. So if you do it once a week for 2, 3, or 4 hours, that's already helpful for your team to stay together as a team. And then you discover possibilities where you can use more programming to step ahead, to go faster, even in software development on other tasks. So yes, it's suited for most teams.
Awesome. Yeah, sounds very interesting.
It is.
Thomas, you had a second session at JCON. It's all about ArchUnit. Maybe you can tell us a little bit about what is ArchUnit actually, and testing of architecture and conventions.
Mm-hmm. I told you in the beginning, I'm a software developer, and sometimes from project to project, I'm in the role of the architect, of the coding architect. And we always talk about architecture. At least that's what I like to do. That architecture is not an occupation of one person sitting somewhere else, and no one knows that person. So we just get some papers describing the architecture, and we have to implement this as developers. I think architecture should be a team sport. We should talk as a team about architecture. We should discuss architecture. And I'm a friend of tools that support such discussions. And ArchUnit is one of those tools. And when I read a tweet, I think 3 years ago, we've released ArchUnit 0. anything. I thought, oh, wow, this sounds like there is a library for testing architecture with my unit testing framework. And actually, that was the idea behind this library. And you can use ArchUnit with JUnit 405, but with any other unit testing framework. And ArchUnit allows you to write your architectural decisions, like which modules should be coupled, which shouldn't be coupled, about dependencies between classes and packages. And you can write these architectural rules as JUnit tests using Fluent API in plain Java. And this way, your architecture lives because you can execute these rules. It's not just written documentation that's dead and lives somewhere, no one knows where. And when you read it 2 years from now, you suddenly realize that the written architecture has nothing to do anymore with the actual code, but you can execute these rules every time you do a build of your software. And the team sees if the software adheres to the rules that the team has set up for itself.
Yeah. Yeah, very interesting. Wow. Yeah, is this already in use at many developer teams, or is this a really new approach to yeah to test your architecture and code conventions? So what do you think?
ArcUnit has been in production, I think, yeah, for 3 years now, and more teams around the world are using it. And when I go around and meet some people virtually these days, I often get some feedback saying, oh, we're using this for this project and that project. So more and more teams are using it because it's an open source library. You can use it, you can contribute to it, and you can just try it in your project. You just include a dependency on ArcUnit, and that's it. And then you can start coding your first ArcUnit rules. And if you like it, you can write more rules. If you don't like it, you just throw it away, which I think you won't do because you will probably like it. But using it is, start using ArcUnit is pretty easy, and it doesn't get much complicated later on. So you can just try it, and I think that's the reason for its success. And I think more and more teams are using it for simple checks for their architecture. Some companies are using it for their larger architectural checks. There's, I think in France, there's a bank that's even developed some plugins for Maven and Gradle for ArcUnit. So even the larger customers, the larger enterprises are seeing the benefits of ArcUnit and contribute actively to it.
Okay, yeah, very interesting. Are there any helpful resources for beginners who want to get started with ArcUnit?
Yes, I'd suggest my presentation from JCON.
Sure.
That's actually, I'll discuss some basics of architecture, what architecture is all about, which different styles exist, and what we can check with ArcUnit. But most of the presentation is live coding. So I'll show you how ArcUnit is working from scratch, that you get the idea how you can use it. And actually, you can use my examples in your real world projects, and it's not that different. And then, of course, there's arcunit.org, the main website, and there you'll find links to the GitHub repo with all the sources, with lots of examples, and with a really helpful user guide. And that's not difficult to read. It's not that long, but it's detailed enough, and it's quite an easy read. So go to arcunit.org, and that's a good starting point.
Very exciting. Thank you, Thomas, for your time. It was really great to have you for this interview and at JCON. Everybody who is interested in mob programming and ArcUnit should not miss your sessions, right? It's now, both videos are now online on JCON.1. Yeah, and if you liked our video, please subscribe our channel. Thank you for your time. Goodbye.
Thank you. Bye-bye.